Arithmetic sequences. Do you see a pattern in each of the sequences? 3, 7, 11, and 15. Well, we add 4 between each term. 8, 3, negative 2, negative 7. We subtract 5 between each term. What do these patterns have in common? We call it a common difference. The numbers in the sequence are called terms. The difference between the terms is called the common difference. If the difference between successive terms is constant, it is called an arithmetic sequence. So here's some generalizations. N is the number of the term we're looking for. A sub n is the term we're looking for, A sub 1 is the very first term, and D is the common difference. The formula we use for an arithmetic sequence is A sub n equals A sub 1 plus D times the quantity n minus 1. Or the first term plus the difference times the number of terms after the first term. So example 1, we have a sequence here. 4, 9, 14, and 19. If we look between each term, we're adding 5 each time. Since the number is constant, it's called an arithmetic sequence. So to determine the common difference we already have is a 5. Now we have enough information that we can write an equation to find the nth term. So we're going to use this formula. A sub n, to find the nth term, we're going to take the first term, which is 4, plus 5, the common difference, times n minus 1. And now we're going to distribute and combine. 4 plus 5n minus 5 is 5n minus 1. So to represent this sequence in an equation, it's a sub n is equal to 5n minus 1, which is a function. Use the equation to determine what the 100th term would be. So all we would do there is substitute 100 in. So to find the 100th term, or A sub 100, we would say 5 times 100 minus 1. So the 100th term is 499. So let's see what this looks like on our calculator. So we're going to go into y equals, and we're going to type in the function 5n minus 1, or 5x minus 1. And now let's look at our table. So we can see that the first term is 4, 9, 14, 19, 24, 29. So it is counting by 5. Now if I wanted to check to see that the 100th term is 499, instead of scrolling down to 100, I can change my table. So here we have table set up here. So we're going to hit the second key, table set, and we want the table to start at 100. Right now it's starting at 0. So we're going to type that in, and then we're just going to hit second table, and the table will go to 100, starts at 100, and we can see that indeed 499 is the 100th term. So that's arithmetic sequence. Now something similar is called the geometric sequence. Do you see a pattern in each of these sequences? 3, 6, 12, 24. Well, we can see that they're multiplying by 2 each time in this sequence. We also have the sequence 8, 4, 2, 1, and a half. We can say that they are dividing by 2, or we could say they are multiplying by a half. What do these patterns have in common? We call it a common ratio. The ratio between the terms is called the common ratio. If the ratio between successive terms is constant, it is called a geometric sequence. So generalizations we can make about geometric sequences is n is the number of term we're looking for, a sub n is the term we're looking for, a sub 1 is the very first term, and r is the common ratio. And here's the equation to find a geometric sequence. A sub n is equal to a sub 1 times r to the n minus 1. So in this example, we have 2, 8, 32, and 28. And by looking at our example, we see that to go from term to term, we're multiplying by 4 each time. So our common ratio is 4. So now to write an equation, we could just write a sub n is equal to the first term of 2 times the ratio, common ratio of 4, to the n minus 1. And here's our equation for this sequence. Now we can use the equation to determine the 20th term. So a sub 20 is equal to 2 times 4 to the 19th, which is a really big number. So let's say 2 times 4 to the 19th, which is 5.49, or we'll just say 5.5 times 10 to the 11. 5.5 times 10 to the 11th. So let's look at our calculator. How would we put a geometric ratio in our calculator? So we could go into y equals, let's clear that, and we're going to type 2 times 4 to the n minus 1, or x minus 1. And let's go and look at our table. Well, remember we had our table starting at 100, so let's go ahead and change our table and say start at 0. And check our table, and we can see our y values are the same sequence: 2, 8, 32, 128, 512. It's getting multiplied each time. So now we could scroll down, or we could go to table set, tell it to start at 20 to find the 20th term. And second table, and there we are, 5.5, and it says e to the 11th. That means times 10 to the 11th. And that's what we have there. So that's the formula for finding geometric and arithmetic sequences.